Good afternoon, ladies and gentlemen. Welcome to Steerix Industry 4.0 webinar series. We are an authorized partner of RWTH Aachen University, one of the top universities in Germany pioneering in Industry 4.0. We have provided trainings and consultation to numerous companies since 2017. Thank you for your participation and interest in our 5-part series. We will be embarking onto part 2 today. The topic of discussion is Introduction to M2M or Machine-to-Machine and Cyber Physical Systems, getting your equipment ready for digital transformation. Mission-to-machine communication is the key to manufacturing success, and now is the best time to start out. Learn how you can quickly get your equipment ready for Industry 4.0 and how you can use cyber physical system to optimize production in real time. Again, we would like to welcome our distinguished speaker, Dr. Hoffmann from Germany, to give a talk. But before we start, a brief introduction about him. Dr. Max Hoffmann is the head of digitization and digitalization, manager at the Institute of Production Technology, IPT, which is part of the Fraunhofer Research Organization. For numerous years, he has been leading the Industrial Big Data Group at RWTH Aachen University and managed major projects with the German manufacturing industry. Dr. Hoffmann conducted projects on digital transformation with many large-scale German and international companies such as Volkswagen, Porsche, Saint-Gobain, and Bosch. Today, he will be giving talk for 45 minutes, followed by another 45 minutes allocated specially for Q&A session. Please raise your concern or question in the chat box. My team and I will compile then raise it to Dr. Hoffmann on your behalf during Q&A. We will try our very best to cover all the questions as much as possible. Without further ado, here is our speaker for today. Dr. Hoffmann, the screen is yours.
Yes, thank you very much, Raghavan. So I think there was a kind of a technical issue, so you didn't maybe hear every word clearly what our host just said. So let me recap a couple of things. So my intent is to give an interactive seminar in which you all learned something. Yeah. So if you have any questions, please feel free to ask. Yeah. Please feel free to raise your hand. Please feel also free to activate your video. Yeah. That I can see who I'm talking to. And yeah. So today's topic is machine-to-machine communication, and we're gonna talk about today how we can make machines talk, and especially how we can enable so-called cyber physical systems. These are systems which can communicate with the sensors, but also have a computational core. Yeah. So without further ado, I would like to jump into the topic. And again, if you have any questions, if you don't understand something, feel free to ask. Yeah, feel free to speak up. This should be an interactive session where you all bring something home from. Okay. Who was yesterday already in our first webinar on Industry 4.0 already saw this graphic here. This is the 9 pillars of Industry 4.0. And one of these pillars, which makes us ready for the Industrial Revolution, is this universal integration. And this is the topic of today's talk. That means today we will deeply talk about how we can achieve this universal integration, the integration of data, the integration of machines, the integration of sensors, and everything else. By the way, is my voice clear or is it slow? Is the connection well or is it not good? Just give me a sign.
We can hear you. Yeah, we can hear you loud and clear.
Okay, perfect. Thank you. Okay, universal integration. So how do we achieve this? Yeah, we would like to integrate all our machines which we have in the factory floor and all our machines which we have in the field, like sensors, devices, programmable logic controllers, and so on. We would like to integrate them into some kind of cloud. And when I say cloud, I don't mean a public cloud from Microsoft or Amazon or whatever. It can also be a factory-owned private company cloud. So we just want to integrate this data somehow in some overall factory systems that we can gather all the information from machines that we have in order to use these for analytics later, to understand our production better, to get an higher OEE, over equipment efficiency, or to optimize our quality or even maintenance. Yeah, these are all reasons why we would like to integrate all this information together in one factory cloud. So how can this be done? Let me show you a few steps how you can make your machines ready for this Industry 4.0 and machine-to-machine communication. So the overall goal is of course the connection of all this. Yeah, and the first step is we connect the shop floor using various devices. Yeah, there's for example a protocol called Mqtt. We will see it later more. There's also heavy machine-to-machine protocols like Opc Unified Architecture. You might have heard it already if you are somewhere in automation technology. We will talk about these different technologies a little bit later. But what we all want to do is we want to create small databases, so-called staging databases in the production, where devices like machines, but also smartwatches, smartphones, and people who are connected, where they can share data and also where they can receive data. So that means we want to upload the machine data that we have from our equipment, but we also would like to have data from the cloud to give us decision support, to tell us what to do. For example, which machine to maintain next, where is a problem in the production which we need to fix right away. All these kind of things is information that we can exchange with this factory cloud. Yeah. So we can, for example, machines can publish data, and this data will be published into this to this cloud. And then the subscription, for example, of a worker who wears a smartwatch or has a smartphone, they can subscribe to important information that comes from the cloud. This can be optimization calculations. Yeah, it can be maintenance tasks and so on. So one technology which has gained major importance in the last years is Opc Unified Architecture. So what is Opc Unified Architecture? This protocol is the first attempt of all big automation suppliers like Siemens, like Bosch, like Phoenix Contact, like Rockwell Automation, all the big automation companies, to find a common language. All these companies are trying to find one protocol where they can all agree to, and which they can all use, and which they can all use also for information modeling. That means giving our data a structure. Because what we want is that every single data point from every single machine is structured in the same manner. This would make it easier to integrate data from several different machines into one big database. And this is why we would like to have this common language, this common understanding of the data that we want to integrate. Yeah. But where do we start in a factory when we talk about data integration? We look at our factory here, visible on top, and we see there is different sort of processes. And there is different sort of data which is produced in these different processes. For example, there is the management resource planning on the bottom left. This is, for example, ERP system data. You might know SAP or something. Yeah, this is the general resource planning data. For example, how many humans are working today? How many shifts do we have? How many machines are available? How many raw material, for example, steel and aluminium and plastics, we have to make the production. All this planning and also the scheduling of the manufacturing is organized within this management resource planning systems. Then we have the manual production controlling data. This is data which is mostly collected by humans, by workers who make, for example, a quality inspection, and they mark something on a piece of paper, or they write something down, or they take notes. So we have this data, still a lot as well. And of course, most importantly, we have this automated production process, which are mostly in today's factories still hard-coded and not really flexible. That means every robot is precisely programmed to do exactly what he does, and not more and not less. So how do we get this different information? How do we integrate this? How do we bring this together? We look at these different layers of the factory. On top, of course, the ERP systems. Who was in my talk yesterday still remember the automation pyramid. Then the manual control data in the middle, and the low level, in the field level, there's all these manufacturing machines and sensors. These manufacturing machines and robots, they are usually connected and controlled to a programmable logic controller, a PLC. This PLC can automatically control the machines, but will also get the data back from the machines. The PLCs can then be connected to a database where they can integrate this data. So we need to find ways that the data these PLCs offers looks the same, basically independently from the device vendor. We want to have PLCs that all speak the same language, that all give us the data in the same way. This is the goal. We also need to find ways of getting this manual recording of information with paper and pen digital. So we need to, for example, develop web interfaces in which people can insert their information instead of writing them down on a piece of paper. And of course, we need to also digitalize all our information from the ERP systems on top here. Some companies still use Excel for scheduling. Some companies use advanced MES systems. This highly depends on the complexity of the enterprise and of your process. But what we need to do is we need to get all this information in a digital way. So how do we get all this data, from different layers into one coherent database? Because if we want to apply analytics and machine learning, and if we want to understand our process more deeply, then we need to integrate all this information into one common storage. So we need to program the computers to transfer its resource planning data into the database. We need to bring our paper management in some digital form to put it into the database. And we need to query our PLC devices using some supervisory and control systems or some M2M communication protocols to also include this data in a database. How is this done practically right now in most factories? As I said before, instead of the paper-based consolidation of information, we can also use, for example, a web application. Then, for example, a user can work with a tablet or even with a smartphone, insert its information, for example, its inspection information, and this data will be transferred to the database via web services. Then we have the machinery and the factory automation systems, and we have the supervisory and control systems. They usually have already human-machine interfaces, but the pipelines to get this into a common database are not really standardized. It means every single human-machine interface is probably programmed in a slightly different manner. And I need to get a special solution for the integration into my database for each single device. Also, the machinery and automation usually uses different field buses, different protocols, different ways the machines are automated. We also need some manual integration steps here. One solution to standardize at least the machinery and automation and the SCADA data is the Opc UA standard. As I said before, the Opc Unified Architecture standard is a standard that is trying to integrate all the information together into one common format. It's the attempt of the big automation suppliers to find a common language, to find a common protocol to enable many more machines to talk to the cloud and to the database. So what OPC UA does is it introduces an information model which can store the data from our field buses and our traditional protocol systems and find some generic integration patterns. Yeah, this way it's way more easy to integrate all the information from the machines, from the robots, from the devices into one database. Yeah. When we have this, then we can go in the next step. This is step 2. So how do we get all this data now from the machines into the factory cloud that we see there above? We need to apply so-called semantics, seen on the top here. That means we need to design information models which gives us a way of modeling the machine. We need to tell the model what the machine can measure, which sensors are attached, how the machine is connected to the PLC. And based on that, we can create a tree-like model, a hierarchical model of the machine, and we can map this semantic modeling on the PLC device. And using this, our PLC device will be able to integrate this information into the factory cloud in a coherent manner. It will know exactly, for example, for a database, in which table to write which information, so that the data it will be neatly structured in the database where we integrate all the data in. So when we, for example, gather the data from the field devices, from field data, gather data from different databases, then we store this information into some factory cloud. Yeah? And based on this factory cloud, then we can finally perform big data analytics. And we can try to understand our data. We can try to find patterns between machine data and, for example, bad quality in products. Yeah, we can try to find these knowledge in the data. We do this, of course, using the semantics from our information model. The information model makes us understand what the data means. And this meaning of the data we need for analytics. Is there a question? I heard the microphone. Okay. So again, please feel free to ask when you have anything that is not completely clear or where you have back questions. Next step is data analytics. So we would like to use all this data from the database to apply analytics. This can be done by machine learning models. This can be done by complex neural networks or any sort of information analysis which you might imagine. Who saw my talk yesterday already knows what is possible with data analytics when we talked about the high pressure die casting process. So with these machine learning models, I can finally apply my knowledge back into the field. That means I can use this knowledge to optimize my production in real time. So besides this very heavy standard of OPC Unified Architecture, there might be also simpler solutions to integrate information into some sort of cloud or into the factory database. A couple of these standards are relying on the so-called Internet of Things. We already talked yesterday about IoT when we talked about the 9 pillars of the Industry 4.0. And IoT standards are supposed to be very lightweight protocols which can easily exchange information between arbitrary devices. So, of course, this is why we can also use these IoT protocols to realize machine-to-machine communication. And I would like to give you a short introduction now in how to machine-to-machine integrate with the Mqtt protocol, which is a very promising standard of the Internet of Things world. So when we look back how automation is being done right now, then we see that most of the automation and data aggregation today is organized using the so-called automation pyramid. You see this here on the left side. On top, we see the systems we already talked about, the enterprise resource planning systems. Yeah? All these systems have data about the scheduling, about the machine availability, the human resources, and so on. Below there's a plant control level, so-called manufacturing execution systems. These systems control the machines, what they do and when they do it. The SCADA level, supervisory control and data acquisition, is a monitoring system. This monitoring system tracks the important events and alarms. Yeah, and for example, when one temperature is too high, this raises an alarm. Below there's a control level, PLC, or in German SPS level. This level controls the sensors, the actuators, the engines, and so on, the machines. And on the bottom, of course, there's a field level. Yeah, this is where the robots and the machines are and the sensors, and where the data is collected. In traditional automation, this pyramid is organized in a very hierarchical manner. That means all the data from the bottom needs to be aggregated through all systems to finally come to the top. This is a very rigid process, which is very difficult to maintain when the systems become more complex. Yeah, this process. So what we would like to do in Industry 4.0, we would like to transform this hierarchical way of using information into some so-called service-oriented architecture, as seen on the right side here. Service-oriented architecture means that all systems can freely talk with each other. That means even the systems from the top can integrate information from the field level directly without going through all these layers separately. Yeah? Because when we want to perform machine learning on data, then we might want to have all the data from the field and not only some aggregated average values. Right? This is why we would like to make all these systems interoperable. And one way of making this is to create a flexible protocol between all the systems. Finally, when we are able to create such flexible protocol, then we can reach our Industry 4.0 maturity. We already talked about this yesterday. In Industry 4.0 maturity, we have to perform the computerization and data connectivity first. This we do with the Opc UA or the Mqtt standard, IoT standards. Then we need the semantic integration. We do this with information models, with the semantics, like shown before. And then finally, after we have this connection ready, then we can use the information storage to build prediction models. And then we can reach finally our adaptable production. Yeah? And in order to enable these 6 steps here to become an Industry 4.0 driven company, the first 2 steps are very important. And this is why I will once again point out now how this connectivity can be done with IoT standards. Yeah? And one standard is, of course, this IoT standard with Mqtt. Yeah. So here's a citation. It's an introduction to the Internet of Things. This quote here says, when wireless is perfectly applied, the whole Earth will be converted into a huge brain. And the instruments through which we shall be able to do this will be amazingly simple compared to our present telephone. A man will be able to carry one in his vest pocket. This is the vision of a smartphone and of the internet. And very surprisingly, this was already set in 1926 by Nikola Tesla, the guy that also inspired the modern car company Tesla. So he had this vision of the internet back then already, and also the Internet of Things. Right now, in modern times, the Internet of Things is defined like this. If we had computers that knew everything there was to know about things, using data they gathered without any help from us, we would be able to track and count everything, greatly reduce waste, loss, and cost. We would know when things needed replacing, repairing, or recalling, and whether they were fresh or past their best. This is the definition of the IoT from a professor from MIT in the US. So Internet of Things basically means that every device can know everything if it is appropriately connected with the internet. Basically, Internet of Things means every device is able to Google for something, is able to find out information autonomously without the help from a human being. Another very important concept is the concept of cyber-physical systems. Yeah? And unlike Internet of Things devices like sensors, cyber-physical systems can also be actuators because they are integrated with the physical process. So this definition here is very, very nice. It says cyber-physical systems are physical, biological, and engineered systems whose operations are integrated, monitored, and controlled by a computational core. Components are networked at every scale. Computing is deeply embedded into every physical component, possibly even into materials. The computational core is an embedded system, usually demands real-time response, and is most often distributed. So the cyber-physical system can be, for example, a little Raspberry Pi device, as you might know it already, yeah, from automation, or a PLC device. It is some device which has a computational core, like a computer, but is also directly connected with a physical process, like a sensor or an actuator. And another nice definition of the IoT is cyber-physical systems are integrations of computations with physical processes. Embedded computers and networks monitor and control the physical processes, usually with feedback loops where physical processes affect computations and vice versa. So that means the sensors influence the computations, but the computations also influence the process. And this is a direct feedback loop, which can be used for direct optimization. So Internet of Things devices are objects that should sense their environment. Yeah, these are devices which are equipped with sensors to see what's going on in the neighborhood. They communicate and participate in business information, also even in social processes, and meaning that sensors and machine will start talking to each other. Usually, every IoT device needs to be a uniquely identifiable object. That means every device needs a unique ID, which you can use to find it, to know where the information comes from. And usually IoT devices also interact autonomously with the physical world. This is exactly what I said before. Autonomously means that the device can gather the information it requires without the help of a human. Yeah. So when we look now on the data integration, what we've seen so far, when we want to get from data to decisions, then the first step is that we integrate this information. Yeah? And we can do this as shown here on the left side by sensors, by databases, by simulations, and so on. So we need to detect, determine, and collect this information before we can consolidate, restructure, model, and integrate this information. Then when we have our integrated information, which is also called smart data, then we can use analytics applications to derive decisions and to derive knowledge from our manufacturing process to make our production finally better. So where does the Internet of Things fit in here? It fits in on the left side. Yeah. On the left side here, this is the part where we integrate all our information. And the IoT standards, the Internet of Things, helps us how to do this. So here's again a slightly more complex picture of the automation pyramid. And I bring this to show you that the automation pyramid is not only hierarchically structured, the automation pyramid also has different communication protocols on the different layers of the machine. So when you look at this gray bars here, which are between the machines and the PLCs and the computers and the ERP systems, then you see on the very bottom, you see Profinet, EtherCAT, Sercos 3 from Bosch. These are all different automation protocols. One layer above, between the PLCs and the manufacturing execution system, you see OPC UA, what we just talked about. We see MQTT, what we'll talk about right now. Different communication protocols. And on top, you see the Ethernet. These are traditional computer networks, like you have them in the office. Yeah? And we need to find out ways how to bring these protocols together, how to make these protocols interoperable, how to enable them to exchange information in an easy manner. So how to reach this communication between these layers? We have to look at different patterns here.
Hey, Doctor,
Yes.
can you hear me? Maybe this is the time to
Yes,
ask the
perfectly.
some question about how the semantic. You mentioned the semantic, like the object, the PLC need to have a knowledge of what the network connection between different devices is. I'm not too sure how does that fit in, like the steps of the semantic. How does that make it aware of the
Yes.
semantic?
Yes, thank you. So what we will do to do this, we will see that the PLC devices, they have a number of sensors attached. Let's say a PLC device usually has hundreds of inputs and outputs. You know this, right? And on these inputs and outputs, we have sensors and actuators attached. So what we do with the information modeling now is we try to create a structure which tells the PLC which device it's connected to which input or which output. And this information model looks like a tree structure. Machine, sensor 1, sensor 2, sensor 3, and then the sensor 1 has further descriptions, for example, which measurement value, the unit, the device manufacturer of the sensor, and so on. And we will implement this information model into the PLC so that all the data we will get from the PLC will have the structure of the sensors which are connected already integrated. Is this more clear?
Maybe I don't have the enough knowledge on this area because it still feel kind of abstract to me.
Yeah, it's abstract, of course. I mean, what we basically do in the PLC is we tell the PLC how which data looks like. Yeah, this is a simple way to say it. We basically tell the PLC sensor 1 has a data structure which looks like this. Sensor 2 has a data structure which looks like this. And if the PLC have all these data structures implemented, then it will also provide the same data structure when we request the data from the PLC to put it into a database.
Can I say that it's just basically to make sure the data that the PLC outputs are of a certain structure that we expect?
Exactly. Perfect. You understood perfectly. Yes, this is correct.
Okay. All right. Thanks a lot.
Okay, thank you very much for the question. So the others, please feel free to share your screen to show me who you are. Would be nice, and also feel free to ask. I would be happy to answer more questions. Okay, so when we look at data infrastructures, we have many different networking topologies and many different networking connections. And one very common in the industry is the so-called client-server topology. This is how all the current field buses are organized, or the CAN bus, which is the data bus in the car. And this is like how traditional technical systems are implemented using a field bus. And the specialty about a field bus is a field bus connects the PLC with all the devices. And the data packages which go through the different devices from the field bus system, they go all in a sequential manner. That means when you look at this animation here, you see that the data can only be transferred when the information signal passes by the sensor or passes by the PLC. This gives us fixed cycle times, but also makes this structure, this data structure between the PLC and between the devices very rigid, yeah, and very hard to modify. So, and there's even more, even worse, there's many different field bus protocols. So just to summarize this page here, there are so many standards. And we don't want to understand all these different and complex standards. What we would like to have is a simpler solution, right? We would like to have a simpler solution to integrate the information from our machines into our databases and into our factory cloud. So when we look about on the history of the internet, we see that there was the Ethernet LAN since the 70s and the wireless technologies since 85 and the mobile technologies since the 2000s. Right now, we are somewhere between 4G and 5G. Yeah, 5G is rolled out right now. And in the industrial sector, we also have some developments. Yeah, one development there was the so-called industrial Ethernet, which basically tried to lift the traditional field bus protocols on the Ethernet level. That means we're using the same cables and the same communication systems as we already use in our computer networks in the office. So there's new standards like you see in the top in the bottom right here, like Modbus TCP, PowerLink, Profinet IO, which are all standards which are compatible to the field bus systems, but which are also compatible to modern computer networks. This way, we can try to integrate the low-level networking systems from the machines and the devices with the high-level networking systems, our computer systems in the office. Yeah, but which protocol to use to make this possible? And which topology to use? Well, there is a very nice pattern which is inspired by the way of communication that's also used, for example, in Twitter and in Weibo. This way of communication is inspired by the fact that you can communicate not only through direct messages, but also through hashtags. I think you all know what a hashtag means. Hashtag means I bring my message in the context of a specific topic. So, for example, I can say, to bring like a very common example right now. Yeah, I can write a message on the hashtag coronavirus. Yeah, so then everyone who has subscribed to this topic will receive this message. And the charming thing about this hashtag way of communication is that the sender of information doesn't need to know who the recipient is. He just needs to know what his recipients are interested in. And then he can just publish information on this topic, and everyone who has subscribed to this information will automatically receive the information. So my thinking is, why can we not use this in machine-to-machine communication as well? Wouldn't it be very nice if we can also make machines publish data on a certain topic, and all the devices that would like to listen to this data, that would like to receive this data, would just subscribe to this topic and would immediately get the data that they want and that they need? So here's an example. Yeah, here's a machine. Yeah, there's a question. Mr. Chong, do you have a question? No? Okay, good. So if we could use all these this topic in machine-to-machine communication, then we could, for example, define a topic which might be called alarms. And there might be certain machines which publish on this topic, alarms, and there might be certain devices which subscribe to these topics. So databases, office computers, ERP systems, but also people with smartphones or smartwatches can easily subscribe to the topic alarms and will receive all the information which is regarded towards this topic. The cool thing is that if we add a machine and a second machine is also publishing on the same topic, the data will be automatically received by the subscribers because you don't subscribe to a specific machine, you subscribe to a specific topic. That means you will automatically get forwarded all this information. So how does this, for example, for the Mqtt protocol works? It's very simple. The Mqtt protocol uses a so-called broker, which you see in the middle here. This broker knows exactly who publishes data and who subscribes data. What the broker does then is it will receive all the published information, for example here from a temperature sensor, and it will forward the information that has been published to all the subscribers. Yeah. Here might be, for example, a temperature sensor which distributes information on the channel called temp, standing for temperature. And the data it transfers is, for example, 25 degrees Celsius. Yeah. Then we have certain subscribers like computers and mobile devices, and they get this information forwarded. They get this information published. So the temperature is published immediately. So what could be a simple solution based on this pattern for modern machine-machine communication? So let's imagine we have our machines in the field, our machines and robots, and they collect and send data, information, and we have a MQTT broker, which is the broker which was before the server, in a cloud. Then he will receive a message from a certain structure. Yeah, we're gonna look in the next step what the structure actually means. But there might be applications now which listen to this, which subscribe to the information from the machines. Based on these applications, we can extract the information, for example, the temperature, and put these information into a database. Based on these databases, we can create so-called dashboards. Yeah, these are, for example, web applications or smartphone apps, which will show us the key performance indicators. Yeah, we have the most important information which can be shown in a dashboard here. And then a worker who might carry one of these smartphones can immediately know what might be going wrong in the production and can directly fix the machines. Yeah, so this would be a very easy to use and simple solution where we use the Mqtt protocol. So in the very end now, I would like to give you a very short understanding of the structure of this MQTT messages. Every MQTT message has a so-called topic. The topic is basically the same like the hashtag is. Yeah. The only difference is here in MQTT, the topic usually doesn't describe only the topic itself, it describes also the location, for example, of the sensor. So here we can see that the topic of a certain message might be generated by a temperature sensor. And the temperature sensor is part of the machine number 1. And the machine number 1 is a drilling machine. And the drilling machine is in the factory. Yeah? With this topic, we can easily define where our sensor is and what the sensor delivers. The second thing that is present in every MQTT message is a so-called payload. This is the actual information which we would like to have besides the information which sensor it is and where it is located. So the payload can, for example, be the value which we would like to have from the sensor. But there can also be a unit, or there might also be another description, which is maybe the sensor type. The nice thing about MQTT is we can extend this. So we can design our payload in a very complex way or in a very simple way. We can only transfer one single variable, or we can transfer very complex data structures. And this makes MQTT so easy to use, but also so flexible. So that means I can get data from very simple sensors, which only transmit one single variable, but I can also map an entire complex machine with a single MQTT message. When we, for example, structure the topics of my different sensors in my factory, then I can easily build up a tree model, like here visible on the right side, where I have my factory, and let's say my factory has several drilling machines, several milling machines, and I can structure all the sensors which are attached to the machines with these 5 topics visible on the left. So with these 5 topics here, I can easily locate my sensors, and I can see immediately what they measure. And this way I can structure my entire factory. Yeah, this is just a very small example here, but of course your factory tree can be very big and very long. Yeah, and you can integrate all the sensors and all the information which you have, you can integrate easily with this system. And what's also important, you don't forget anything, because you see immediately if something is missing in a tree, right? So you can very easily implement all the data sources of your factory here. So with this last words, I would like to thank you very much for your attention. And of course, we still have half an hour, even more, for questions. So please feel free to dig deeper here and ask me questions.
Okay. Now it's time for Q&A. So we do have questions in the chat box, but any of the attendees, if you have any questions, you can actually you can have like questions. It's kind of a bit awkward to just look at our laptop and talk, right? So I urge all of you to feel free to ask as many as questions as possible to Dr. Hoffman, related to this topic or even any other topics, right? Any question? All right. So I think there's one question from Razali Hussain, right? He's asking, how do we go from here?
Okay, yeah, this is okay. This is also a very general question, but let me try to answer this. Yeah, so how do we go from here? So basically, there's 2 ways how to go from here. Yeah, what you can actually this really depends what you're looking for. Are you looking for a short success story, or are you looking for a long strategical implementation in your company? Yeah, so let me just examine this 2 ways a little bit. If you're looking for a short success story, then it would be actually quite feasible to start with the IoT protocols, yeah, to maybe get a Raspberry Pi device. I can look, if I got some Raspberry Pi device here, I can show you what it is. Yeah, for example, this is the Raspberry Pi device, and these little devices here you can also use for prototyping in a factory, right? So, and what you can do is you can attach some sensors to them, or even some PLCs which have open interfaces to them, and you can try to implement one very simple integration using the MQTT standard, which you just seen. It doesn't really require a lot of programming. Actually, you can implement this quite easily. By the way, one of our seminars that we offer together with Stierix and the RWTH Aachen is precisely on this. Yeah, in one of our seminar on CPS and M2M, we actually develop such a success story with you together. Yeah, so we teach you how you actually implement the MQTT in your practical applications and how you can make your first success story here. So the second point which I mentioned is the long-term strategical implementation. For this, you also have to talk, of course, to your automation suppliers. Yeah, so you have to find out if your PLCs have open interfaces, how you would implement something like a Opc UA information modeling. And again, here a training can also be quite helpful. Yeah, we have also a training on how to model using Opc UA Unified Architecture, how to design these information models, how to get information from complex PLCs, and even how to integrate them into a database. So did this answer your question, how to start from here, or do you have any maybe more specific question or any specific problem which we can discuss right now?
Okay, I think another question from the same person. How can I convert existing RTUs GSM based into M2M?
What do you mean precisely with GSM based?
So
Maybe you can just unmute. Maybe you can just unmute your microphone and we can discuss this. Please feel free. Don't be shy. Yeah, we can. We are a very nice round here, and we can just discuss this. I would be glad.
Encik Razali, can you hear us? Okay, he's trying to get his mic on. So let's wait for him.
Okay, good.
Okay. Okay. Can you hear me?
Yes, perfectly. Thank you.
Okay. I have some old project which is actually GSM based remote terminal unit,
Yeah.
and I understand there is that you can convert that into M2M based GSM, and from there I could actually move on into kind of going to the cloud, and then I can be able to extract the info.
Exactly.
Is that possible?
Exactly. Yeah, this is possible. I don't know precisely which GSM system you are using right now, but I can imagine that this might be a fixed solution by some supplier. And the problem with these fixed solutions is very often that they are very rigid and you cannot make any decisions about the data structure you get. So it's very difficult to integrate this information into some cloud or into some generic database. So what we could actually do together, and we could also even do this during a training, yeah, that we try to find out which interfaces you might have on your machine, which the GSM system connects right now. And we can try to use these interfaces to integrate the data in a more open way, in a more generic way. Yeah, and then we can use this information modeling, and we can use this integration patterns that we've seen before to save the data into a database. But I think this can be done.
Okay, thank you.
Sure. Any more questions?
No more. At the moment, none. At the moment.
Thank you. So to the others, please feel free to ask. Yeah, I would be happy to understand more where you come from, what sort of factory you're working in maybe, or what sort of production environment, and how we can try to modernize it.
Okay, Dr. Hoffman. Meanwhile, waiting for the question from the audience, right? So this is some common question that we always get, right? When we go for a meeting with companies or clients, right? So based on your presentation, we can understand, based the mission can be communicated. One mission can communicate to another, right? So I think most of the SMEs are still kind of skeptical or maybe curious. So I have this old mission, right? So even when you answered Mr. Razali, you mentioned that what kind of interface that mission has, right? So I have this old mission. So how do I make this mission communicate to another mission in my production floor? So what do I need to look for in this existing mission? And what do I need to do first in terms of hardware for this mission to talk to another mission? Probably the language, the data structure is something that we can look into after we go through some training, some making them to talk in a common language, right? Because probably now each mission might be talking in a different language, right? Like a human being, right? But now I want to make them speak in English, for example, right? So that's secondary. But the first thing, what do they look for in their mission to know that, okay, now this mission, old mission still can be converted to life? Because they always have this worry, oh, do I need to change the whole mission, right? I think you always come across this kind of questions, right? So
Exactly.
yeah, so if we can be specifically give an example, what they look for, what they can do, right? And so that could kind of be uh, uh, an eye opener, or probably they know, okay, it's feasible to do it stage by stage. It doesn't require a heavy investment, a big investment, and kind of thing, right?
Yeah. So this is a very good point. Thank you for that. So the discussion is, of course, every manager and every factory owner would say, never change the running systems. Yeah, that means a machine that exists and which is working very well, it will probably not easily be replaced by a newer machine. This is why, in fact, we have to deal with older machines. And we call this so-called legacy systems, or the brownfield, who listened to my talk yesterday. Yeah? And these legacy systems, we need to find ways also to integrate these. And the first step here is always talk to the supplier, talk to the vendor. Most of the vendors which provide the machine, and probably also the PLC which controls the machine, they have adapters. They have adapters through which you can access the data using a generic protocol, for example, Opc UA. For example, one major supplier of PLC devices is, of course, Siemens. Yeah, many of you might know this very big German company, Siemens. They sell a lot of PLCs, and they have a very high market share in the automation technology market. And they, of course, they also have very old PLCs, even from the 80s, which are still in place and which are still working in factories. But they offer so-called connectors, adapters, which convert the old protocol representation into, for example, Opc UA. Yeah, and when I have this adapter, then I can easily bring my data into a common language. So most of the machine vendors and most of the PLC suppliers offer such kind of adapters, such kind of, they sometimes also called CP modules. Yeah, and you should definitely contact your supplier in the first step and ask him, how can I connect to my machine? Possibly already asked him, how can I connect with Opc UA? Because this would be the most straightforward and future-oriented solution to go for. Anybody here in the audience who already tried a project in machine-to-machine communication or tried to get information from a machine? Anyone here, what kind of problems did you face? How did it work?
So in summary, you are saying any machine is able to be converted or able to communicate to another machine.
Yes. Every machine can be made Industry 4.0.
Right. So that pretty much sums up to, solution to most of the SMEs, because this is a big concern to most of them, right? Right. So we have another question from Lee. Since we are new to this and would like to start with a simple project, example, predicting mission maintenance based on defects, how would you recommend we approach this project? We have the data from our MES. Can we transfer the data to a machine learning engine to achieve this? Right. So I'm now trying to start machine learning studio to see if it can be done. Right. So basically, they have a predicting machine maintenance based on defect project. Right. So they want to know how they can approach this project.
Yeah. So this is sounds to me like a very nice project, and by becoming the MES data, this is already a first and very important step. But let me just first of all say, actually predictive maintenance is usually not an easy task. Yeah, so it requires really some analytics skills, and it requires some work, because sometimes it's hard to find the patterns in the data. But if you already have your MES information, this is already a very, very good start. What's very important is, in the next step, you need to try to combine your other production information with this data. Yeah. So you need to find ways of how to bring the other information together with the MES data, to actually apply some analytics method to find these patterns. So what does this mean? Yeah, so you have your MES data, which basically tells you when you have machine downtime, when the machine is working, when the machine is not working, and so on. In addition to this, you also need your sensor data and your quality measurement data. And all this data needs to be stored in connection to the same ID. You would like to have, for example, an ID for the products. You would like to have an ID for the machine. Yeah. And when you have all this data together, directed towards one ID in a database, then you can start your first data mining project. Yeah. And the data mining can be done with actual Python programming, but there's also graphical solutions, for example, by using RapidMiner or some programs like this. Yeah, actually, in another seminar which we offer in combination with Sterix and RWTH, we do exactly this. Based on the machine-to-machine communication training that we offer, in the next step we also offer this how to apply machine learning seminar. And there we will have some practical data sets where we do precisely this. We learn how we can use analytics methods and some easy programming to achieve something like a predictive maintenance forecast. Yeah. So did this answer your question, or is there any more specific problem you face right now, which I can maybe help with?
Mr. Lee, feel free to.
Thank you. Thank you for answering my question. But actually, I would just like to know what kind of tools that I can probably start because we don't actually have the full budget for this. So we're now right now kind of doing like a POC. Just want to find out that see whether it's a working model to prove that this is working before we can uh, embark on a full project. This kind of the proof of concept.
Yeah, so what I would actually recommend is to use some open source tools. Yeah, some tools which are free of use. And for example, tools which we use in our trainings are, for example, the so-called Node-RED environment. It's spelled Node and then RED, R-E-D. And this is a graphical programming environment, which is based on the Node.js language. And you can use this graphical programming environment to design data integration tool chains. So when you already have a connection to the PLC, you can use this sort of integration tool chains to, first of all, save your data into a database, or maybe in the first step into a CSV file or some data file. And then for the analytics part, I would actually recommend to learn Python programming. I know it sounds very difficult in the first steps to learn programming, but the Python language is a really easy to use and easy to learn language, and it has some very powerful libraries. And basically, if you start out, you can already design machine learning models with a few lines of code. Of course, we also would recommend very warmly to go into training, to learn this in a very structured and in a 1 week compact seminar where you can learn this. But for the tool suggestions, I will say Node-RED and Python.
Okay, thank you.
Sure.
I think, thanks, Mr. Lee. Thank you, Dr. Ahmed. We have another 3 more questions, right? So first one is from Mr. Wyman Chiang from M2M, right? So he's asking, what does the term digital twin mean?
What does the term digital twin mean? Okay, yeah, this is a very interesting question as well. The digital twin is the concept of the virtual blueprint of a real device or of a real product. So let me try to put this in simple words. Let's imagine you manufacture a car. Yeah, then this is a very complex product which has a lot of different components and also a lot of different devices and sensors and so on. When I would like to create a digital model of this real world car, where I can find all the sensors and all the devices which are attached to this car, and where I can model and analyze all this information which the car is composed of, then this is called the digital twin. So the digital twin is basically the system view which I have in my database or in my virtual planning tool, which tries to precisely match the real thing. A digital twin can also be a digital twin of a process, by the way. Yeah. So if, let's say, I have a process which consists of 3 steps, and in each step there is performed a different action, or there is performed different measurements, then the digital twin can also be the twin of my entire process. So I try to map all these different information gatherings and all these different control mechanisms also using my digital twin. The digital twin has the purpose of understanding your process in a mathematical way, in a digital way, yeah, to make products or processes analyzable. This is what the digital twin is for. Did this answer your question?
Yes, it does. Thank you.
Thank you.
Okay, thank you, Mr.
So any more questions? Please feel also free to ask the questions by yourself. Yeah, you can maybe even give me a clear understanding what you would like to know.
Yeah, okay. Mr. Tay, do you want to go by yourself or you want me to ask you? Can you turn on your mic? Okay, probably I'll just ask on your behalf, and then if you want, you can just add on later. All right. So there's a question from Mr. Tay. Hi, Dr. Hoffman. The IoT or cloud computing capabilities is very dependent on the connection speed. So that's a question mark. All right. So the IoT capability is very dependent on the connection speed. And what I mean here is the data can transmit instantaneously for computing process. So to improve the IoT capabilities, the only solution is to improve the tracking. Is there any other solution? It looks like he's emphasizing more on the speed. Is the speed is the main concern? Is there anything else that they need to look into?
Yeah.
Correct me if I'm wrong, Mr. Tay. Yeah.
Yeah. So actually, really have to say, I do not agree with the statement. IoT majorly depends on the network speed. I think IoT is even if I have a very bad network connection, is the best solution ever, because IoT protocols have a very, very light footprint of data. An MQTT message is very, very, very small. And in IoT concepts, I also have the so-called message queuing mechanism. Message queuing means that I have some local storages next to my machine, which will store the data if the network speed is low. Yeah. So if my network is overloaded and I'm not able to distribute all the information at this point in time, then my message queuing systems, for example, an MQTT broker also already does this, they will queue the messages. It means no message will be lost. They will locally stored like your computer stores local information in the RAM. Yeah. And when the network is free again, then these messages are all transferred in the next step. So I have to say, even if you have very low networking speed, then it's even better to use IoT protocols in favor of all other protocols. But feel free to discuss this with me. Maybe you have a specific use case which makes it difficult to implement. I would like to understand this.
It looks like he's fine with your answer. He's happy with your answer. Okay, thanks,
Okay.
Dr. Hoffman,
Thank you very much.
to clear his mind. Right. Okay. So, Encik Razali would you like to ask the question? Right. Will you be able to?
Yes.
Hello.
Hello, I can hear you.
Okay. I'm Saiful from Robert Bosch Penang.
Hello.
Okay. Hello. Can you hear me?
Yes, perfectly.
Okay. For your information, I'm currently doing sensor project in Robert Bosch Penang, and in Bosch facilities here we have IoT gateway, and then we have several sensors connected to this IoT gateway. For example, we have a pressure sensor and also XDK devices. So these sensors are connected directly to the Bosch IoT gateway, and then we have Node-RED application. As mentioned by you just now, we used to pull all the raw data and save in CSV file. And
Yes.
then for the current system architecture, we need to run this Node-RED in a desktop PC as a host. So means that whenever we need to pull all the data, we need to always run this Node-RED application. So I would like to ask you whether is it possible for us to have this kind of data saved in share folder without running this Node-RED application. Is it possible?
Yes, of course, it's a possible. It's also easy possible, but it's also easy even if you keep the Node-RED application. You know, the Node-RED application just makes it easier to model the information integration. But my question is, why don't you use a Docker container to deploy the Node.js application on a server? It would be very easy. I think I could set this up in half a day. So what I would actually suggest is that you set up a small server, and don't get me wrong, a small server can also be a Raspberry Pi device very easily, or can be just a small computer that runs day and night, and you can actually deploy the Node.js application in a Docker container. That means like in a sort of virtual machine. And this virtual machine can be in a cloud, and it can be local somewhere, and it can be always accessed from anywhere. Yeah. And of course, what you can also implement with Node.js or Node-RED, or even with the host computer itself, is a bash script or a batch script, which will transfer all the CSV files onto some networking drive. Yeah, so I think this is this can be very, very well integrated. So if you need support there, please contact me, yeah, or contact the guys from Steerix, or stay in the call afterwards, and we can work something out how we can maybe support you.
Yes, sure. Actually, I'm working this project with my colleague, but he's not joining this meeting. So maybe we can have a separate meeting together because he's the one who responsible on the system architecture. So maybe we need him also our discussion. Yep.
So please feel free to write me an email, yeah, or something, or
Sure.
or to contact the hosts from Steerix. Yeah, please feel free to contact us. Okay, and we can. I'm sure we can work something out.
Yes. So this is your email?
Yeah.
Okay. Thanks. Thanks a lot. I think that's all from me.
Okay.
Thank you.
Thank you very much. Yes.
Right, for the client, right? So as he told earlier, the remote terminal unit
Exit
reading
from
analog.
my message to the chat.
Yes. I can hear you, Mr. Hussain.
I had this meeting. I mean, I had this system installed in 2012. The thing is, as I said before, it's a GSM based, but there's also another mode that we have not used, which is GPRS, and we wanted to upgrade, but the client would like to know, would the budget be too big, or or if there will be a lot of modification or side job. I mean, side job. That's I want to know. And is there any way of cutting down the expenses if I were to move from it's an RTU, which is, I think it's old SCADA system, but I think it's built by us, You want to actually to take it to move into 4.0 and so on, and that kind of thing. Thank you.
Yeah. If I understand this right, you have a SCADA system which is in place right now, and you would like to implement a more future-oriented solution here. Yeah. So the costs basically. So there are some fixed costs which you can really not avoid. This is the costs of the supplier offering the interfaces, right? So if the supplier of the current systems or current machines, they require a certain payment for opening their interfaces or to implement interfaces for the connection, these costs cannot really be avoided. But the major costs for the implementation of these kind of systems and the integration of this information, they can be drastically cut down if you take the strategic decision that you or some of your engineers actually learn how to do this. What the colleague from Robert Bosch said before, they also doing it by themselves. They designed a Node-RED Node-RED application which they use to integrate their data from their MES systems and so on. And you don't need to be a professional IT person or a professional implementation expert to implement this. This can be, I would say, every engineer can learn this in a week. And so this is my suggestion here. Take a training and or let your engineers take a training to cut down this implementation costs. Because this would be, of course, very expensive if you let your supplier also provide for this. But if you have the knowledge by yourself, which I would very much recommend, then the only fixed costs you might have the suppliers offering the interfaces to you.
Thank you very much.
Okay, thank you, Engineer Ali. Dr. Hoffman, last question to finish this off, right? So, right now we are talking about machine-to-machine communication. So, most of the time, the people who are dealing with production system are mechanical background or electrical background, process engineer or electrical engineer. So, for them, is this like a big step for them to learn this and implement it in production? Because we already spoke about from management point of view, director or as an organization point of view, what they need to do in terms of implementing machine-to-machine communication. But the person who needs to do this is the engineer themselves. So some of the participants or the engineers or workforce may be skeptical. Okay, they don't know programming, or they think that it's kind of difficult for them to learn programming. So when you talk about this, right? So probably you could give an advice, give them an eye-opening statement saying that, okay, how they can do this, how they can easily learn and implement this, in their daily job, as well as some piece of advice for, students or future workforce.
So we already mentioned this before. I think the world of IT and also the world of implementation has majorly changed in the last years, which means that implementation and programming and developing IT solutions have become way easier. They are very nice and easy to use tools where basically every engineer that is able to use a computer can learn how to perform these kind of implementations. And this is why I think no matter what your engineering background is, if you are an engineer and if you're eager to learn, then these systems and these models which we proposed can be also easily learned by you. So don't be afraid of these. And yes, of course, if you have some free time and if you would like to engage a little bit with, for example, data integration, I would really recommend to have a look into this Node-RED application. Yeah, it's very easy to use, very easy to install also, and very easy to implement.
All right. Thank you so much, Dr. Hoffman. So with that, we can wrap up sharp 3 o'clock, right? So thanks again to Dr. Hoffman and all of you who have participated. We appreciate your time for being with us. Hopefully this talk and Q&A session has benefited you guys, right? So again, this talk was brought to you by Theorix and MPTE, PN, and MGCC. So stay tuned for part 3 via email. We will be sending you emails. We have all your registered account emails. So we will send to you again when is the part 3 where we will be discussing about data analytics, right? And if you need any assistance, kindly email us at info@theorix.net. So the email address is in the chat box as well. Thank you, everyone. Have a good day.
Thank you very much. Goodbye.